So this video is a continuation of my series on the locus of complex numbers. And I showed you in a previous video that this forms a perpendicular bisector between points Z1 and Z2, which describes all the locus of points where Z could possibly be. If you're not sure what I mean by this, you should check out my previous video. I'll put a link in the description below. Okay, so we're going to use this property to sketch the locus of Z and find the Cartesian equation for which this statement is true. Okay, so we need to start by identifying Z1 and Z2. Well, Z1, we can see, is Z minus Z1, so Z minus Z1 becomes 3 plus 2i. And for Z2, we've got Z minus, so Z minus, if we write this out, we'll have the negative 2, but then we need a negative I, because when you multiply this negative by the negative I, this becomes a positive I. So Z2 then will be 2 minus I. And if we plot these two complex numbers on our Argand diagram, well, Z1 will be approximately here at coordinates 3 and 2, and Z2 will be approximately here at coordinates 2 and negative 1. So the locus will be a perpendicular bisector between these 2 points, which would look something like this. And we can see this because the distance between Z1 and the locus is exactly the same for both coordinates. Okay? So now we need to find the equation of this equidistant path between the 2 points. Well, if we let Z equal x plus iy, then we substitute this into our equation. We've got the modulus of x plus iy. We'll expand out these brackets. Minus 3 minus 2i will be equal to the modulus of z, so x plus iy, minus 2 plus I. Now, we've got a collection of real and imaginary parts, so we can group these together. So if we have a modulus of x minus 3, and these are our real parts, plus I, and the imaginary parts of y and negative 2, then this will be equal to x minus 2, the real parts, plus I, and then y plus 1. Okay? We can find the magnitude of both of these by Pythagorizing them. Then we'll find the magnitude as the square root of x minus 3 squared plus y minus 2 squared. This will be equal to the square root of x minus 2 squared plus y plus 1 squared. So now we can square both sides and expand out the brackets. So we've got x squared minus 6x plus 9 plus the y squared minus 4y plus 4. This will equal x squared minus 4x plus 4 plus y squared plus 2y plus 1. And then you can see this x squared will cancel with this one, and this y squared will cancel with this one. And now we can collect the constant terms together and simplify both sides. So negative 6x minus 4y plus the 13 will equal negative 4x plus 2y plus 5. Now we can move all of these terms over to the right-hand side. So 0 will have negative 4x plus the 6x, the 2y plus the 4y, and then the 5 take away the 13. And this is the equation of this perpendicular bisector. And we can check this works by rearranging it in the form y equals mx plus c, because we'd expect a negative gradient and a positive intercept. So if we've got 2x plus 6y minus 8 equals 0, we'll move a negative 8 to the right-hand side, take away the 2x and divide by 6. So y will be 8 minus 2x divided by 6. And we do have a positive intercept and a negative gradient. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from our website, mythmathematics.com. There's a link in the description below. Thanks again and take care.